Alright, so what is a polynomial? Not necessarily. I mean, we can use polynomial to describe something with more than 3 terms. Yeah, so what is a monomial? 1 term. What is a binomial? 2 terms. What is a trinomial? 3 terms. Well, poly, the prefix poly just means more than one, many, multiple, right? So basically, any of those can also be described as polynomials. A binomial and a trinomial are also polynomials. They're just kind of specific. After that, we don't really have words for like 4 terms and more terms. It's just a polynomial. So remember, we're looking at things that have just one variable. They have to have a real number coefficients, so you can't have things with i's in them. And they have to have whole number exponents, so no fractions and no negatives. Does that make sense? So we're just looking at things like x to the 3rd plus 2x plus 1. X to the 20th plus 10x squared plus 2, right? Doesn't matter what the number of your exponent is, it just has to be positive and it has to be a whole number. Agreed? Okay. So for today, we're going to look at some of our graphing properties. So the first thing that we're going to look at is our end behaviors. So ends, meaning our ends of the graph. It doesn't really matter what happens in the middle, so that's why there's dashed lines, because it's saying I'm just looking at the ends. Now, remember that when we're talking about an x, y coordinate plane, if I'm on the right side of my graph, what are my x's going towards? Right, so this would be x, and then we just draw an arrow. So going towards positive infinity. If I'm on the left side of my graph, what is x going towards? Negative infinity, right? Because my x values would be getting smaller and smaller and smaller as we go to the left. So as we go up, what are our y values or f of x values going towards? Positive infinity. And as we go down, negative infinity. So basically, you're just looking for the combination of your x and your y for that arrow. Yes?
We have root figures that
For? Yes. Alright, so if I'm looking at this first one, notice that if I'm on the left side of my graph, I have x is going towards negative infinity. Agreed? Yeah. Same thing with my second one. As I'm on the left side of the graph, x is going towards negative infinity. When I'm on the right side of the graph, x is going towards positive infinity. And then from there, you just have to decide, is it going up or is it going down? So when I point down, my f of x goes towards negative infinity. As we're going up, f of x goes towards positive infinity. Does that kind of make sense? Now, what type of graph, equation, would give us 2 sides that point the opposite direction? So a cubed. Anything else? Would a squared?
No.
No. Would a fourth?
No.
No. Would a fifth?
Yes.
Yes. So what do 3 and 5 have in common?
Odd exponents.
They're odd exponents. So what do we call it when it's the biggest one?
Degree.
So your degree is odd, means we have opposite directions.
So just plain X would do the same thing. No?
Correct. Because remember you have a line, right? So your line, they point opposite directions, yeah? Now, to know which one goes, like which way, we have to think about the leading coefficient. Okay? So if we think about our leading coefficient of, say, x cubed, what does our x cubed graph look like? Kind of like the S shape, right? And if I just think about my normal x cubed graph, we go down on the left and up on the right. Agreed? So what would make it be the opposite and go up on the left and down on the right? A negative where? The leading coefficient in front of the x. So in general, if our leading coefficient is positive, it's going to go down on the left and up on the right. If our leading coefficient is negative, it's going to do the opposite. So if my degree is odd, it means they go opposite directions. What does that mean about my even degrees? They're going to go the same direction. So even. They point the same direction. Now again, whether they point up or down is going to depend upon our leading coefficient. So if they both point up, what is our leading coefficient? Positive. And if they both point down, negative. So in general, it might be helpful to have something like this. So if I have even, odd, I'm just going to abbreviate. So LC is positive, LC is negative. Okay. So if it's even, right, they have to point the same direction. So in my leading coefficient, they will both point up. If it's negative, they will both point down. If it's odd and we're positive, the left is down, the right is up. And if it's negative, then it's the opposite. So it's just kind of like a quick cheat sheet reference chart to kind of tell us what's going on. Does that make sense? Now, like I said, that's kind of a cheat sheet as far as my arrows. However, if I ask you, okay, to state the end behavior, we need to use the correct notation. And so that's going to be the stuff with the infinities and the f of x's and x's. Okay, so let's look at an example with that. So remember, we talked about looking at our leading coefficient and looking at our degree. So we don't actually have to graph this in order to be able to tell what our end behaviors are going to be doing. So what is my degree of the first one? What is it specifically? 3, yes, which is odd. And then what is our leading coefficient? -1, and -1 is less than 0, right? So, what are the ends of this graph going to do?
Not be in the same direction.
They won't be in the same direction, and then because it's negative, they will specifically be up on the left and down on the right. Now, we can use that kind of to help guide us, but like I said, this is not our answer. You can also not put up, left, down, right. Okay, that's not going to cut it either. We need to use the correct notation. So if I'm talking about the left side of our graph, what is x going towards? negative infinity. So as x goes towards negative infinity, what is f of x doing? Is it going up or down? Up. And so how do we say up? Positive infinity, right? Because my y values are getting bigger and bigger and bigger and bigger. Now, if I want to talk about the right side of the graph, x is going to go towards what? Positive infinity. Then what is my f of x doing? Now it's going towards negative infinity. Agreed? Alright, so for my second one, what is our degree? 4, which is even. So what are they going to have to do? Go in the same direction. What is our leading coefficient? 1, which is greater than 0 or positive. So what direction are both of my ends going to point? Up. So as x goes both ways, right? My f of x is going up. So instead of writing two statements, we could say as x goes towards positive or negative infinity, f of x is also going towards positive infinity. So it just cuts down on the writing to write it down as 1. But that's only if they're doing the same thing. If they're doing opposite things, then we have to write two statements. Now, be careful. Someone last hour asked, do you have to put the positive infinity? No, not necessarily, but just be careful because some of y'all's handwriting, like, you'll write an infinity, but then you'll, like, do an extra little dash, or it's hard for me to tell what your infinity sign is. So then I can't tell if that's a negative infinity or just an infinity. However, if I always put the plus sign in front, now I know for sure that it's a positive infinity. So just be careful with that. You don't have to put it, like I said. It just makes it a little bit easier to distinguish. All right, so now I want you to do the last one on your own. All right, it looks like most of us got an answer. So my degree is 5 this time, which is odd. And our leading coefficient is 1, which is greater than 0. So my sides are going to be opposite. And the left side's going to be down, the right side's going to be up. So that basically means that our signs are going to match. So as x goes towards negative infinity, f of x is also going to go towards negative infinity. And as x goes towards positive infinity, f of x also goes towards positive infinity. Do we have any questions on end behaviors? Alright. So, next up, we're talking about zeros. We've talked about this slightly before, so you don't have to write all of this down. Basically, what you need to know is that having a zero, a solution, a factor, or an x-intercept all mean the same thing. The biggest thing to note, though, is that for your factor, remember that the sign is going to be opposite of what your zero or your x-intercept is at. Which is going to be important when we're looking at our graph, either trying to get the equation or make the equation. We're going to have to flip the sign of our factors. I mean, you might. It shouldn't take that long. So, let's look at an example. So, remind me, if we're looking for our zeros, and that's the same thing as our x-intercepts, what is our y value for our x-intercepts? 0. So, what do we want to do with f of x? Make it 0. So, you would have 0 equals negative 2x to the 4th plus 2x squared. And then we're solving for x. But how do we solve for x on that? So what have we talked about in this class? Yeah, we can factor it. So what factors out of that? Remember, we always want to check and see if we have a greatest common factor. 2x squared. And then what are we left with? Negative x squared plus 1. Be careful in this second term, because remember, if I have 2x squared and we factor out a 2x squared, it's the same thing as dividing. So we're left with a 1, not a 0. Because a lot of people just want to write negative x squared there on the inside. But then if I multiplied it back out, I wouldn't get what we started with. So remember, you do have to put like that placeholder of 1. So once I get it factored, what do I want to do with my factors? Set each of them equal to 0 separately. So we just get that x equals 0. And then what do we get over here? X squared equals positive 1, right? Because we would subtract 1, divide by a negative. And then we would take the square root, so we get x equals plus or minus 1. Now, hopefully some of us recall a property. How many zeros am I supposed to have? As many as are on the graph, okay. But how could I tell how many I'm supposed to have just by looking at the equation? That's how many mins or maxes you should have. It's 1 less than the degree. So how many zeros should we have?
A good amount.
As opposed to the bad amount? Okay. I heard someone say it. What is it? How do I know it's 4? Because it is the degree, right? So your number of zeros should equal the degree. Okay, so how many zeros do we have? What's our degree? So am I missing one? No. Even if we factored it, right? So what would happen was if we had imaginary solutions, we would get those by factoring. But there is like a catch here. This includes repeated roots. So how many times does 0 actually happen? Or what's the degree when I set it equal to 0? 2. So technically x equals 0 is repeated twice. So I would have x equals 0 and x equals 0. So that counts for 2 of my zeros. And then we have positive and negative 1. So that's what gets us up 4. Does that make sense? Yes. Questions on that? Alright. So let's look at another one. So we have p of x equals x cubed minus 2x squared minus 3x. We're looking for our zeros. How many zeros should I have? 3. I agree. And what do we do to find those? Well, what do we have to do before we can factor? Set it equal to 0, right? That's how we have to start. And then, yes, we want to factor. So what can we factor out this time? And x. And we're left with x squared minus 2x minus 3. So what are we left with on the inside? Specifically, what type of polynomial? Specifically, what type of trinomial? What did we talk about on Monday? Quadratics. So it's a quadratic, right? So how do we solve quadratics? Or how do we factor them?
Reverse FOIL.
Okay. What do I call it? The AC method. So our A is 1. So we're just looking for what multiplies together to give us -3. That adds together to give us -2. So what do we get? -3 and a positive 1. So then what does x equal? 0. And x minus 3 would give us positive 3. And x plus 1 would give us -1. So notice this is why we end up with the opposite sign in our factor. It's because whatever our 0 is, in order to undo the factor, it's the opposite operation. So that's why the x minus 3 gives us a positive 3, and the x plus 1 gives us a -1. So how many factors did we get? 3. So we're good to go. Alright, we have another kind of theorem-y thing, or rule. We talked about repeated roots. So we had just like x squared, right? So that's a repeated root at 0. But you could also have like x minus something, and it could still be a repeated root. So you got x minus 2 to the 3rd. That's repeated 3 times. And if something is repeated, we actually have kind of a rule about what our graph is going to do. So if it's repeated an odd number of times, so like I said, if I had a 3, my graph is going to go through the x-axis. So there. Goes all the way through it. However, the opposite is true. If it's repeated an even number of times, so like it's squared, so like on our last one, what 0 would be, it's just going to touch the x-axis, but then come back up. So it doesn't go through it. Are we all okay with that? So again, we're just kind of learning some properties to help us be able to graph things and to be able to look at graphs and determine what the equation might be. an example. Basically, we're going to use all of the knowledge that we've talked about now to help us be able to graph it. So, what did we talk about first?
Behavior.
Our end behavior. So, what is our degree of this function? What's the biggest exponent? It's 3. We all okay with that? Not as 3, even or odd? It is odd. And then what is our leading coefficient? Nope. Negative 2, which is negative. So what are our ends going to have to do?
So as x goes from -3, y is going to go up.
So we'd be up on the left and
Down
down on the right. So since it doesn't ask us to state the end behaviors, we're just going to use it to help us graph it. We can leave it like that. We don't have to write the statements out. We just kind of want to envision to start like what our graph is going to look like. So then how many zeros should we have? 3, because that's our degree. So how do we find those?
solve it.
By setting it equal to 0. Now, what's going on with that last term? It's a fraction. Do we tend to do well with fractions? Not sometimes. Depends on the fraction. Now, notice though that I have an equation now, right? So if I'm solving, as long as we do it to both sides, we're allowed to do it, right? So what might be helpful to try and get rid of the fraction?
Multiplying by 2.
Yeah. So if I multiply 0 by 2, what do I get?
0.
Still 0. So then as long as I do it to everything, that should be plus, that should be a cube. I'll fix it in just a second. We would get just 9x there, right? Which is easier to deal with than the 9/2. So now, what could we factor out? We can factor out an x. Can we factor anything else out? Yeah, like we would probably want to factor out a negative just because, remember, it's easier, usually, for us to factor things when our leading coefficient is positive. So I'm going to go ahead and factor out a negative. So then what are we left with? 4x squared minus 12x plus 9. So what do we have in our parentheses? A quadratic. So we need to look at our AC, which would be 36. So we're looking for what two numbers multiply to give us 36, that add to give us negative 12. So negative 6 and negative 6. So then I'm going to use a bracket since we're going to be factoring here. We would have 4x squared minus 6x minus 6x, because remember we are factoring by grouping. So we can factor out a 2x from our first group, and we're left with
2
minus 3. And then what do we need to factor out of our second group? A negative 3, and we're also left with 2x minus 3. So once it's all factored, what do we have?
2x minus b squared.
Yeah. So do we all see that we are going to have 2 of those?
Mm-hmm.
So what's going to happen at that root?
It's going to touch it and change.
So it's gonna not go through it, right? It's gonna touch it and go back the same direction, either from the bottom or from the top, depending on what the rest of our graph looks like. So what are our zeros in this case? Agreed. So 3/2, and 3/2 is repeated twice. What else? That's only 2. We need one more. 0, right? Because we have to set the x, negative x, equal to 0 as well. And that would just give us x equals 0. Agreed? Okay. So, now we have zeros at 0 and at 3/2, which is 1.5. Okay? Now, what else do we know about our graph? We have our zeros. We also know that this side has to go up, the left side, and the right side has to go down, correct? Now, is there anything after 0 that we're allowed to cross through the x-axis? No, I found my 3 zeros, which means that we cannot cross the x-axis anywhere before 0. Agreed? And if we know that my left side has to point up, we know that basically we're going to have to come down from the top until we get to 0. Does that make sense? Are we all with me? If you really wanted to check yourself and make it super accurate, you could plug in a number. But I'm okay with just a rough sketch at this point. So then, at 0, what's our degree for just our x here? 1, right? And is 1 even or odd? Odd. So does it go through there?
Yeah.
Yes. So we know it has to go through. Okay. And then we know eventually, somewhere, again, if you want to plug in a number, you could, but it's going to have to come back up to 3/2. Now, what happens at 3/2 though? It touches it, but it doesn't go through it, right? So then it would come back down. Which, remember, again, we want our right side to be pointed down, and we know that there's not another 0 after 3/2, so we know that that's what the rest of my graph is going to look like. So again, if you wanted to plug in like 1 or 2 points to get a more accurate graph, you could, but that's basically all I'm looking for at that point. Are we okay with that?
Yeah.
Where did I get the 3/2? So if we set 2x minus 3 squared equal to 0, right? I would take the square root of both sides. Well, the square root of 0 is still 0. Then I would add 3 and divide by 2. Does that make sense? Same thing here. Technically, I set negative x equal to 0, but negative 0 is the same thing as 0, so we just get x equals 0. Does that make sense? Other questions? That was a good one. No? Okay. So, here we were given an equation, and we needed to find a graph. We could also do it the opposite way. We're given a graph, and we have to write an equation. Now, I will tell you, if I ask you to write out the equation, you don't have to multiply it all out. You're just going to write it in factored form, okay? So when it says 8th degree polynomial, you're not going to have to write out something with 8 terms, right? We're just going to have to make sure that we have 8 factors. Does that make sense?
Yeah.
Yes?
Yeah.
Okay. Now, remember, how do we get our factors? We said our factors are the same thing as what? Our zeros, which are also our x-intercepts on our graph. So, where do we have x-intercepts this time? -3, -2, -1, and 0. So, if x minus 3, if x equals -3 is an x-intercept, what would my factor be? +3, right? Because it would be x minus -3, which is the same thing as x plus 3, right? Because remember, it has to be the opposite of whatever our answer is. Agreed? Okay, so if x equals -2 is an answer, what would our factor be? +2. And if x equals -1 is a 0, what would our factor be? plus 1. And then if x equals 0 is a 0, what else do we have to have?
Just an X.
Just an x. Okay. Are we all right with that? So that ensures that we have the right zeros. Yes? But we also have to look at the other stuff on our graph. Because it tells us that we want an 8th degree polynomial, right? So right now, if this is degree 1, degree 1, degree 1, degree 1, 1, 2, 3, 4, I'm only going to get a 4th degree polynomial. Are we all okay with that? But notice what's happening at -3 and -2.
They're just touching it.
It touches and goes back up. So what has to happen at those degrees?
They have to have like an odd or an even number.
They have to be even, right? So, like 2s. So that would be 2, 4, 5, and 6, right? But I'm not quite there yet. What can we do instead?
Make one of them 4.
You make one of them a 4.
Does it matter which one?
Nope. So there's going to be multiple answers for something like this. Does that make sense? The last thing that we have to consider, though, is our ends. So we know that it's going to be the same because it's an 8th degree and 8 is even. So they both have to point the same direction. But what does my leading coefficient have to be? Is it positive or negative? Positive, because they both point up. Now, if they both pointed down, you would just stick a negative at the front. And that would be fine. Does that make sense? But like I said, I do not expect you to multiply that all out, right? Like that would be your answer. You just leave it in factor 4. You all with me? You're gonna the practice that you're gonna be doing on Friday is gonna be asking you to write out functions based upon the graphs, and I want you to leave it in factored form. I don't want you spending 30 minutes trying to multiply all that out. Does that make sense? All right.